When I pitched reviewing this study to my producer, he said, "You want to talk about a drug no one is ever going to use?" Yes. Yes, I do. The drug is tecovirimat, and the disease it treats is smallpox. Smallpox, through the power of vaccination, was eradicated in 1980. This is Rahima Banu. She was one of the last recorded cases. She survived, by the way. You can see why this was such a triumph of global public health. Smallpox is transmitted via an airborne droplet route, and the fatality rate is 30%. The basic reproduction number, also known as R0 of smallpox, is 5 to 7, meaning each infected individual infects an additional 5 to 7 people on average. The multiplier effect is huge. Smallpox has been eradicated, but variola, the virus that causes smallpox, has not been eradicated. It exists in isolation in labs in the US and Russia, and hopefully that is all. Could smallpox be repurposed as a bioweapon? Even taking the US and Russia out of the picture, the entire genetic code of variola is known, meaning a bad actor with sufficient technical skill could potentially synthesize the virus from scratch. After nearly 4 decades post-eradication, herd immunity is gone. A smallpox outbreak could kill hundreds of thousands if we're lucky, millions if we're not. Luck favors the prepared, though, so it seems reasonable to create medications that could treat smallpox after the infection appears. Enter this article, appearing in the New England Journal of Medicine. Tecovirimat was identified via screening of more than 350,000 unique compounds. It's an inhibitor of p37, a highly conserved protein present on 98% of orthopox viruses, and prevents formed virions from exiting an infected cell, halting the infection in its tracks. But how do you test a drug for a disease that no longer exists? Well, smallpox may not exist, but monkeypox and rabbitpox do exist and have been validated as animal models for human smallpox. Would tecovirimat save animals infected with these viruses? The results were fairly compelling. The mortality rate for monkeys infected with monkeypox was 95% in the absence of the drug. With treatment, initiated at 4 days after the monkeys developed skin lesions, the mortality rate dropped to 0. Similar numbers were seen in the rabbitpox model. How does the drug affect humans? Well, 412 healthy volunteers participated in a pharmacokinetic study to figure out the appropriate human dose and to see what adverse effects there were. The adverse effects weren't too bad, pretty similar to placebo, with a bit of an uptick in headache and gastrointestinal symptoms. With this data, tecovirimat is on its way to FDA approval. The FDA's independent scientific advisory panel voted unanimously that the drug's benefits outweigh the risks. But how well will the drug work in a human infected with smallpox? Well, let's hope we never find out. For MedPage Today, I'm Perry Wilson.